Have you ever really thought about that little blue dot on your phone? How does it know exactly where you are, right down to the sidewalk you're standing on? Well, the answer doesn't start with a satellite. It actually starts thousands of years ago, with people just looking up. So let's dive into this incredible story of how we learned to find our place on Earth, all by looking at the stars.
Okay, so first things first, let's get our heads around the basic problem. I mean, before GPS, before you even had a simple compass, imagine you're out there, maybe on a huge, featureless ocean or lost in a massive desert. Humanity was facing this really fundamental challenge. How do you even know where you are? And maybe more importantly, how do you know where you're going?
No, seriously, think about this for a second. You're out there, it's just sand and stars as far as you can see. You don't have your phone, you don't have a compass. How in the world do you find a fixed direction, like north? You know, this isn't just some fun little puzzle. For ancient travelers and surveyors, getting this right was a matter of survival. It was the absolute foundation for building a civilization.
So what did they do to solve this? Well, they did the only thing they could do. They looked up. And they started to realize that while everything on Earth was shifting and changing, the heavens offered something stable, something predictable that they could literally anchor themselves to.
And this quote right here, it just nails the core idea perfectly. Think about it. Our planet is spinning, it's orbiting the sun, it's tilting on its axis, it's in constant, complicated motion. But the stars, for all practical purposes, are these fixed points of light way out in the distance. They create this ultimate cosmic reference grid, these celestial anchors that we can use to figure out our place on this spinning rock. And of course, being humans, we love to turn a clever art into a formal science. This whole practice got a name, geodetic astronomy. Let's just break that down real quick. Geo means Earth, and you know astronomy is for the stars, so it's literally the science of using the stars to map the Earth. It's the critical bridge that connects the cosmos, way up there, to the coordinates right here under our feet.
And you know, this wasn't just some abstract concept. For the surveyors who were literally drawing the map of our world, this was everything. See, a compass points to magnetic north, which actually wanders around. But the stars, they point to true north, the actual axis our planet spins on. And that's what lets you get an absolute position, which makes sure that a border or a highway that you're building for hundreds of miles actually ends up where it's supposed to. And this last point, this is the real kicker. These same astronomical frameworks are still the foundation for our modern satellite systems.
So let's actually get into the history here, because the journey of how we figured this all out is just incredible. We're talking about civilizations that built the world we know today, with tools that, yeah, we might think are primitive, but their understanding of the cosmos, it was anything but.
Every great civilization kind of laid a new brick in the foundation. The Mesopotamians, they gave us the basic language of geometry we still use, you know, the 360-degree circle. Then you have the Egyptians, who took that and applied it with just mind-boggling precision. They perfectly aligned the Great Pyramids with stars. But the real game changer? That came from the ancient Greeks. They're the ones who shifted from just watching the sky to actually calculating it, turning the whole thing into a math problem they could solve. And that brings us to one of the most brilliant experiments in all of human history, performed by a Greek librarian named Eratosthenes. His goal was, well, it was pretty ambitious. He wanted to measure the entire circumference of the planet. And his high-tech equipment for this job? 2 sticks. That's it. The logic here is just, it's so beautiful. Eratosthenes knew that on one specific day of the year, the sun shone straight down a deep well in a city called Sienne, meaning it was directly overhead. But in his own city, Alexandria, at that exact same time, a stick in the ground was casting a shadow. He measured the angle of that shadow and found it was about 7.2 degrees. He realized this difference could only happen if the surface of the Earth was curved. And here's the brilliant part. Since 7.2 degrees is exactly 1/50th of a full 360-degree circle, he figured the entire circumference of the Earth must be 50 times the distance between those two cities, which he already knew.
So what was the result? His final calculation was accurate to within 1% of the actual size of our planet. Just let that sink in for a minute. 1%. With 2 sticks and some really clever geometry, over 2,200 years ago, a single person measured the entire world. It's absolutely staggering.
So how in the world did we get from Eratosthenes and his sticks to the pinpoint accuracy we have in our pockets today? Well, it's a huge leap for sure. But the core principle, measuring angles against a fixed reference point, that never actually changed. We just got much, much better at doing it. The jump in accuracy over time is just wild. For thousands of years, the best you could hope for was accuracy within a few kilometers.
Then, in the mid-20th century, we started using the Doppler effect from early satellites to get a little closer. The GPS era, well, that brought us down to just a few meters using signals from multiple satellites. And today, with all the global systems working together, we can pinpoint a location down to a few centimeters. It's just incredible.
And this really puts it all into perspective, doesn't it? We've basically traded looking directly at the stars for receiving signals from our own man-made artificial stars, our satellites. But the basic goal is identical: use fixed points in the sky to find our position on the ground. The only real difference is that we've gone from an accuracy of kilometers to an accuracy of centimeters.
So, with all this unbelievable technology, does any of that ancient knowledge even matter anymore? You might be surprised. The answer is a huge, profound yes. It's not just history. It's the active, living foundation of everything we use today.
So here it is, the final crucial connection. What do you think our amazing satellite systems use to make sure that they don't get lost up there? They are constantly being checked and oriented against that same fixed reference frame the ancients used, the positions of super distant, unmoving cosmic objects. So, in a very real way, those ancient celestial anchors are still holding our modern digital world perfectly in place. So the next time you look down and see that little blue dot on your map, just remember the incredible journey it represents. From 2 sticks in ancient Egypt to a whole network of satellites orbiting Earth, all of it resting on one timeless idea. It kind of leaves you with a final thought, doesn't it? If all that technology just disappeared, could we still look up at the night sky and find our way home? Thanks for joining me on this explainer.